Hello everybody. In today's video we're going to learn about quadratic graphs and their properties. So we're going to start off by showing you a quadratic function. We talked about this last year, this year. Quadratic function is just a function that can be written in this form. This should look familiar because this was what we were factoring last chapter. The only thing different is that we're putting the y in here. So now instead of just saying the expression ax squared plus bx plus c, now we have y equals ax squared plus bx plus c. This is also known as standard form because, as you can see, the variable x here is in descending degree order, so x squared and then x and then no x at all. Remember, the a, b, and c are not actually variables. That's where the numbers will be, whereas the x squared and the y, those will remain as variables. So this is standard form as well. The quadratic parent function, which is like the most basic version of the quadratic formula, or not quadratic formula, but the quadratic function, is y equals x squared. The graph of that looks something like, let's see, 2, 3, 4. So the graph of y equals x squared looks something like this. My lines aren't going to be great here, but you get the idea. That U shape is called a parabola. You'll see in a moment that it could also be an N shape. The axis of symmetry is this invisible line, which sometimes we show as a dotted line, although you can't really tell. I'll put it off to the side a little bit. Is a dotted line to show like where this mirror is, because you notice the right side and the left side are mirror images of each other. So what we call that mirror spot, that invisible line down the middle, is called the axis of symmetry. The vertex is the lowest point in this case, or the highest point in the case of an N shape, right there on the bottom. That's the axis. The vertex. The vertex also shows the minimum point and the maximum point. So in the case of a U, this would be the lowest point on the graph here, and if it were an N shape, and I'll just put an N shape over here, then the vertex would be the maximum value of y. Alright, so let's graph some of these. Y equals negative 4x squared. Before actually I get to this problem, I forgot about something. So I set up a graphing calculator here online to show you the parent function. So here we have y equals, and the y1, the y2, y3, y4, that just means we're going to be able to graph several equations on the same coordinate grid here. So the first one, we have y equals x squared. I'm going to graph that for you. It'll come up in red. So there's the parent function. And you notice from back in the factoring days there that the a value, and it's non-existent here, so the a value equals 1. So the a value can be larger, so if I put 2x squared, and we can graph that, that'll show up in green. You notice that it gets narrower, right? Because as x increases, the y value increases even more than the parent function because we're multiplying it by 2. And then I could put a 3 in there, or whatever I want really, and I'll graph that. That'll come up in blue, so it's even more narrow. And then I could put a 6 in there, and that'll come up in yellow, and that's even more narrow. Also, take a look at what happens when I put a negative in front of here. Remember, this negative is not affected by the exponent, so let's see what happens. Okay, all the graphs turn into n's. Okay, and then you have maximum y values instead of minimum y values. Alright, so back to this problem here. So if we need to graph this function and identify the domain and the range, I'll get to the domain and the range in a minute, but to graph it, we just make our xy chart. 5 points minimum to show a quadratic function. Some good ones to use for now. We're going to make this better next video, but for now we're going to use -2, -1, 0, 1, and 2. So if we plug in -2 here, we get 4 times -4 is -16. If we plug in -1, we'll get 1 times -4, 0 times -4. Okay, and then you'll notice we'll get 1 times -4 and then 4 times -4. So you'll notice we get some repeats on the y values there, which is expected because we expect that mirror image and the points to come up the same way on both sides. Notice I haven't shown an XY axis yet. The reason for that is because I want to see where my y values end up to decide where I should put the axis. So I'm just going to put it up high because I know that my y values are all pretty negative there. So I'm just going to make it like that. It's not perfect, but you get the idea. And now I can graph it here, -2, -16. So 2, 4, 6, 8, 10, 12, 14, 16. There's that. And then I have -1, -4. Okay. And 0, 0, 1, 4, and 2, 16. So this is a very narrow graph because the A value is -4, whereas it would be wider if the A value were smaller or larger in this case, or closer to 0 or closer to 1. Alright, so there's our graph. I don't expect it to be perfect when you're making it, but I do expect to see a curve and 5 points. As you can see, our axis of symmetry is right down the middle. So if we wanted to show it, we would show a dotted line, and we could label the axis of symmetry. The vertex here is at 0, 0. And this question asks for the domain and range. The domain is all possible values of x. So we know we can plug in any value of x here and forever and ever. So the domain is all real numbers. The range, however, which is all values of y, will never be greater than 0. So the range, we just say y is less than or equal to 0. Okay, whereas x is all real numbers. Alright, let's try one more. So here we have -1/2 x squared. It's done the same way. Don't be scared off by the fractions. We all know how to deal with fractions. Again, I'm going to just pick the same values for x, which we'll update in the next video. So if x is -2, we have 4 times -1/2, which is -2. And then if x is -1, we get 1 times -1/2, 0 times -1/2, and then 1 times -1/2, and 4 times -1/2. So now we have some smaller numbers. So although we are in the negatives only, my graph can just be at the normal height because the numbers are quite small. Well, that line's not very straight, but you get the idea here. It might help for you guys to use a straight edge when you guys are doing this on your paper. You will need graph paper, of course. Alright, so if I was going to graph this, we got -2, -2, -1, -1/2. That's about right here. 0, 0, 1, -1/2, and then 2, -2. Okay, so this one's much wider. That's because it's fractional. Number less than 1, so it's even going to be wider than the parent function, as opposed to the narrow graph we had last time. It's not a perfect curve there, but you get the idea. So the domain in this case, again, is all real numbers. The range in this case is same as the last one, so y is less than or equal to 0. You'll see as we graph more of these tomorrow and the next day that the axis of symmetry will not always be in the same place, the vertex will not always be in the same place, and the domain and range can be different. Although the domain is always going to be all real numbers, the range, however, will change. Alright, that's it for this video. Thanks for watching.